Start the recording. Well, it's great to see everybody here. It's February 24th, and hopefully you had a great holiday a week ago. Haven't seen you in 2 weeks. Did you guys miss me? Maybe, maybe not. Okay. All right. So we've got hopefully we've got a lot to do today. So I've got a list of things to talk about. And one thing, especially naturally, all you guys want to get through this course. I want you to get through this course. And so I just want to remind you that, two things as far as that are required as far as being successful with this course is that you got to be able to keep up with the announcements and keep up with the work. Sometimes since we only meet once per week, it's easy to kind of put it off and after class today not think about statistics for a while, but that's not a good plan. All right. And so what I wanted to call your attention to is certainly a couple of announcements. And again, be sure to keep an eye on Canvas. You should be receiving email reminders of, can you guys hear me? I just realized my picture here froze up.
Yes.
Okay, cool. Oh, it looks like I unfroze. Okay, cool. Occasionally I will be asking you that. Sometimes weird things happen. We all know with technology, and especially with all the crazy weather going on, who knows? If I do go quiet or freeze up for some reason, feel free to say something in the chat. Sometimes what happens, I am managing from both my computer and my tablet. And so usually one goes out, not the other, unless my internet goes out. Now, if my internet goes out for some reason, then watch Pronto, because I have my phone right here and I can always go ahead and send a message through Pronto saying, okay, my internet's out right now, give me a few minutes. I can always turn my phone into a hotspot, or sometimes I need some, anyway, might need a few minutes to get back on. So anyway, what I wanted to call your attention to is certainly the announcements. Now, one of the things I did highlight the importance of coming in prepared and doing the media assignments. I do rely on you coming into class prepared and not hearing this material for the first time. So definitely do the media assignments. My lab, you have to do the media assignments. You probably noticed this and get at least an 80% on them in order to open up the corresponding homework. So you want to keep that in mind. Also, we have a test next week. I'm going to be talking about that test. That'll be the last thing we talk about today. So I'll save some time to get that done. Also, I wanted to remind you, I know with the media assignments heading into today that there were some sections with some tedious, ugly calculations that might scare you away. And so I wanted to reassure you that StatCrunch is going to be doing that for us. So when we get to those sections, I'm thinking, I think it's 3.3 and 4.1. StatCrunch does those things for us very, very nicely. And so those are a couple of things that I'll be talking about today when we get to those sections. So the main thing is, again, keep up. And don't let yourself get behind. Keep an eye on the announcements. I'm not going to be sending you daily announcements and you're going to get tired of whatever. Okay. I will be sending probably a weekly announcement if there's something important or an important reminder. And I did send one announcement this morning. Hopefully you saw it. I was checking my lab and noticed that some of you, your 14-day trial has expired. Okay, so you need to take care of that as in right now. Okay, that should have been taken care of before, because I did mention that in an announcement a week ago. But of course, our quiz today is going to be through my lab. And so if you've let that expire, you will not be able to take the quiz. I do drop everyone's lowest quiz. Sometimes people miss quizzes for all sorts of reasons. And so that's why I drop everyone's lowest, and that'll get dropped at the end of the semester. But so if you missed the quiz today, or for some reason you're not able to extend the MyLab access, well, then today's quiz can be one that's dropped. Be the one that's dropped. Now, in today's announcement, I did give you, there's a little link right here with some instructions on how to upgrade the access. And that's a YouTube video. And it basically, what you do is, I actually have it right here. When you log into MyLab, before you click on the class, you click on the upgrade access, and then so you can see there it says upgrade access, and then you can upgrade two ways: either an access code. An access code is what you would purchase through the bookstore, but I assume you're not going to run to the bookstore right now, unless you're on campus. And then the other is the credit card or PayPal. Now it says this price. This is not our price. This is a general YouTube video. So our price should be around $75 or $85. I think I forgot what the price is. I've got different prices in different classes. But anyway, so this is something, again, in order to take the quiz today, you got to have access to the MyLab now. All right. So let's go ahead and get started with other things. Let's see. All right, what did we do last time? Well, last time I'm going to bring up the notes. Last time we went over chapters, chapter 2, and then a couple of sections in chapter 3. And so chapter 2 was basically on pictures, okay? Chapter 1, that was all the definitions. You learned all of those. Then chapter 2 is about organizing and making a picture of the data. And so what we did is, our first group of pictures that we talked about was for qualitative data. So remember that qualitative means that there's labels. That's categorical data. Again, things like eye color, maybe asking your major or your religion, or things that are categories. And so the main things we talked about is certainly once you gather your data, you have to organize it and do something, and we call it a frequency distribution, and that tells you how many things are in each category. Frequency means how many. If you see the words relative frequency, you want to think of, like I highlighted there, a percent. You calculate a percent by taking how many divided by your total. All right, so there's frequency, which is just the number, how many, and then relative frequency, that is it could be in decimal, or let's see, where are we on the notes? I'm going to go move the notes here. There we go. Can be in, yeah, and you can see right here, I did that in the notes. It can be in decimal, fraction, or percent form. Okay, so let's see. I think that's all I want to say about 2.1. Oh, and then there are bar graphs and pie charts. And you got to look at these in the homework. So with that, anybody have any questions on 2.1? Just so everybody knows, I typically will give a few reminders in each section, kind of the highlights, and then take questions from that section. So if you've been doing the homework and there's a certain problem you had trouble with, then we can take a look at that problem. And if it's in one of the other sections, well, we'll get to those in a few minutes. I like to take it one at a time, so I'm not bouncing all over the place. So anybody have any questions on 2.1? If I bring that assignment up, and here we go. So you can take a look at your notes and see if you have any questions. Now, as you're doing the problems, hopefully you're doing the problems in a notebook and keeping track of what you're doing, and not just using little pieces of scratch paper that'll get thrown away later. Because certainly your homework and what you're doing is a great way to study for a quiz. Okay, the quiz today, and of course the test next week, will involve pretty much problems that you've done in the homework, not the exact numbers, of course, because my lab gives everybody different numbers, and well, with quizzes and tests creates different problems. But as long as you can do what's in the homework by yourself without help, then you should be in pretty good shape for the tests and quizzes. All right. So last call. Any questions on 2.1? Are we good? Not seeing any? Nothing. I'm not seeing anything in the chat. And again, one little reminder is if you chat me at John Zarski host. There's host and co-host. Co-host is my tablet, and I'm not looking at the chat there because I'm keeping my screen clear. You can see my screen. And so one of the reasons I use my computer is so I can keep the chat, keep track of it on there. So last call. All right. All right, well then let's go ahead. 2.1 wasn't too bad. So I can understand if you didn't have very many questions on that. Let's go ahead and take a moment and look at 2.2. Okay, so now with 2.2, this is where we focused on quantitative data. So quantitative data is data that involves quantities and numbers and how many things. So I could ask you, like, what is your age, or how many units are you taking, or anything that pretty much involves a number is quantitative data. And then the typical pictures that we use for quantitative data. And one thing we see all the time in the real world is a histogram. And that's basically a bar graph for quantitative data. Now you see here, we also use the words frequency. Remember, frequency means how many, and then relative frequency, that's where we're talking about a decimal fraction or percentage. And so we can also do that with, again, quantitative data. And so let's see, we talked about frequency, yes, frequency distribution. Oh, and the next thing we talked about, you can see here that we use for one possible picture that we use for quantitative data is the stem and leaf plot. All right. Oh, there's also dot plot. We looked at that. And wait a minute, where's stem and leaf? Wasn't stem and leaf around here someplace, or did I skip it? Right, hold on a second. Let me get my notes. I have them back here behind me. And so let's see. You know what? Stem and leaf was in 2.3. That's why. It used to be in 2.2 in an old version of this this book, and then they moved it. So, all right. Now, one thing here in 2.2 is 4 ways to describe a set of data, 4 descriptors, 4 words that we use. One of them is uniform, and that's where, the word uniform, like when you wear a uniform at work, it means you're all wearing the same thing. So a uniform distribution means basically a flat histogram, and everything is pretty much the same. And so an example of that, I have examples on the next slide. And uniform, now it doesn't mean it has to be perfectly flat, but just kind of flat. Okay, maybe some bars are a little above or below, but for the most part, it's mostly flat. The next one is bell-shaped. We're going to see that a lot, and we're going to use the word normal to describe bell-shaped. And then skewed data that's skewed to the right means that you have outliers or extreme values on the right, and then skewed left means you have extreme values or outliers on the left. And I think that's it. Yeah, that's it for sections. Yeah, section 2.2. So anybody have any? Oh, I see some things in the chat. Let's see. Oh, Ariana, I see you have a question directly to me. You asked about where do we find the slides? That's a great question. Let's go ahead and recap that. The slides are found in my lab. So where you go, it's now the path. Let me show you where the path, in case you forget, maybe you're half asleep or something right now, haven't woken up, coffee hasn't taken effect. The path is written in the syllabus. So if you click on syllabus in Canvas, and you can see right here, PDF versions of the slides are located at My Lab, Communication Tools, and then that says Document Sharing. So what you do is you go to My Lab, you go to Communication Tools. It's along the left side and down toward the bottom. Okay, see I have Communication Tools right down there. Click on that, and then Document Sharing. Some of these other options you won't see in yours, but the main paths you will. So Communication Tools, Document Sharing, and then all the files are right here, at least the ones you need for the test next week. You see that I have lots and lots of files. Actually, you know what? I've opened up everything you need for the semester. It's organized according to chapter. And so, but you can see I have everything here. And so you'll see the chapters 1 through 15 that you need. And then I also have, lab assignments and all kinds of other stuff here. So did that answer your question? Cool. Ariana? And
thank you.
oh yeah, Jessica, you were asking the same thing. PowerPoints. Yes. Jasmine. Yeah. My lab. All right. So looks like we're good there. Anybody else have any other questions? I guess I didn't think to, it's only our second day. It's the end of the third week. So I've done 3 weeks worth of stuff in my other class, but really this is the second day that I've seen you. So usually on the second day I ask, are there any just kind of technical questions about the class, about my lab, about anything else? So certainly if you have any questions like that, feel free to ask along the way. So let's see, with 2.2, again, 2.2 was on quantitative data. And so anybody have any questions there? I know these assignments are a pain, maybe kind of mind-blowing to keep track of. And as far as when they're due, what do you need to do? And one thing that I would always suggest is keep up on your course home. Your course home, My Lab, will always tell you what you need to do. And so, like, for example, you see all kinds of things due next week. All right. Now, if you need any extensions or anything, stick around after class and we can look at it. Remember, I do have an office hour, an hour after class. Also, what was I going to say? Oh, yeah, I do have a virtual office hour before class for a half hour. And what I've been doing, and I think I'll just continue to do this, is just start the Zoom session early. So if you have any questions for me, certainly feel free to come early. Coming early is a good thing. And also, for those of you that came late, it's better to be on time. I did not mark you here. I'll be taking a look when we take the quiz a little bit later, but yeah, being here on time is a good thing. And also I'm keeping track of showing live video. So in order to get part of your participation points for today, there are 4 participation points for today. And part of that is showing live video. The other part is participating when I ask a question, ask you to post the answer to the question on Pronto. So a couple little reminders. All right, last call. Anything on 2.2? Let's see, 2.2. Now, I'm generally pretty generous with extensions on homework, especially if you've already done it. If you've already done it and you haven't gotten 100%, hey, I'll give you as many extensions as you want. If you haven't done anything, then we have a little bit of a different conversation as to why we're not keeping up. And because again, this class, we if we just meet once a week, you have to keep up if you want to be successful in this class. So, we talk about, okay, what's going on? And so, but if you come up to me, if you've tried it, let's suppose you've gotten 75% on the assignment and you say, hey, Mr. Zarsky, can I go take a look at that and get the 100%? I mean, think about it. You're asking me and saying, Mr. Zarsky, can I do more homework? What do you think I'm going to say? Of course. So, again, if you've tried the assignment and, because of the conversation we had in class, you're like, you know what, now I get it a little bit better. I'd like to go back and get 100%. I will open it up for you. Okay. So again, keep that in mind. If you need any extensions or anything, stick around after class. I'll take care of them right away, or send me an email or message me. Now, if you do message me, I need 3 things from you. I need to know your name, which class you're in, and which assignment you want extended. Okay, those 3 things. I have 3 classes and I don't have it memorized who's in what class. So that's where you guys, my Math 219. I only have one Math 219. So if you just tell me, hey, Mr. Zarsky, this is so-and-so, and I'm in your Math 219 class. Could you please extend and then list the assignments? Now, right now, I would extend the medias at this point. Now, you're supposed to get those done before class, but I'm usually a little bit forgiving in the beginning. But after next Friday, I will not be extending medias. I'll just simply open up the homework, and then you take a 0 on the media assignment. All right. So again, kind of get everybody into the program and up to speed. There won't be any extensions on medias after today. So anyway, all right. Last call, 2.2. Oh, I see it. Okay. Oh, Alyssa, I just saw your message. That's kind of a long message. I think I'll have to reply to that during the break. Or when we're taking the quiz a little bit later. I'll take a look at that message. Anything else? Last call, 2.2. Are we good? All right. All right. Well, then let's go ahead and we'll say a few words about 2.3. Now, 2.3, that's where we did get the stem and leaf plots. So let me pull up PowerPoint for 2.3. There we go. Okay, so you can see here that we have 4 pictures that primarily we talk about here in this section. You can see stem and leaf plots, frequency polygons, cumulative. Now remember, cumulative means total. And then time series, that's a graph over time. And so we described both of those. Now the stem and leaf is a little bit different. You can see you take your data. We had some data right here, and you divide it up into left digits and right digits. And the stem and leaf, like you see my description right there, I wrote that it's a quick and dirty way to summarize and make a picture of the data. And this is a stem and leaf is not something we would do for the general public, or if you're doing a report for work or something, presentation. It's just one of those things to quickly summarize the data and see what's going on and see if there's any kind of a, if it's uniform, bell-shaped, skewed right or skewed left. But stem and leaf plots are kind of interesting. And then there was the frequency polygon. Like I said, the frequency polygon if you think of a histogram, but you take away the bars and just use a point, a dot at the middle, and you can see I have the midpoint marked. And so that's one way to summarize data. And then we talked about the cumulative frequency. Cumulative, again, it's a total up to a particular point. And we looked at one of those in the book. And hopefully in your notes, you might have seen that. I didn't write down what page that was on. Or maybe I did. Did I do that? Frequency polygon. I said, let's see. Let's see. Nope, I didn't show what page that was on. So that was yeah, 2.3. Oh, that's page 98. So for the cumulative. So let me just write that, put that on the notes. That was on page 98 in the book. Page 98. Okay. All right. Okay. And then the last little thing, one thing we see quite a bit in the real world is the time series. And the time series, that's where you have a plot over time. And sometimes in the news, you see the, picture, they show like gas prices over time, gas prices going up or down, stock market going up or down, all kinds of things. Anytime we show data over time, it's a time series, and we see those a lot in the real world. So anybody have any questions on section 2.3? All right. Oh, again, awesome. I see a question. I was beginning to get concerned. So let's see. You say question, problem number 4, you say 4E. What I'll do is I'll go through, I'll just go through the whole question because my lab doesn't let me skip to the section unless I can look at a printout if it's too long, but it should be okay. So let's go to 4 and see what's going on. Oh, interesting. Time series plot. Okay, so let's go ahead. Let me bring up a blank whiteboard so that I can write some things down. So this is now 2.3, problem number 4. Now, let me show you something. If you look at the code, there's a code next to each problem. You can see this here. It says question number 4, and it says 2.3.13. Now, what that code means is that's a code for the problems in the book. And it means that this problem is like section 2.3, problem number 13. So if you wanted to refer to the book, you could find that problem similar, different numbers, but similar problem, and that would be again in the book. So you can read the code and you know what it's telling you. Okay, so let's see what's going on with this problem. It says the time series plot to the right shows the annual unemployment rate and annual inflation rate over a period of 19 years. So complete parts A through F below. Okay, so estimate the unemployment rate in year 5. Okay, unemployment, that's the blue. So year 5, that looks like about 8%. Okay, let's do that. Good job. Hey, we're off to a good start. In what year was the unemployment rate the highest? Okay, unemployment rate the highest looks like 16. Yeah, that looks like it's the highest right there, just a little bit above 8. So that would be year 16. All right, in what year was the inflation the highest? Let's see, where is that point? That looks like year 9, doesn't it? Okay, so let's do that. 9. Excellent. Okay, and then in what year were the unemployment rate and inflation rate the closest? Well, that looks like year 9, would that be? That looks like the closest. So let's see, year 9. Okay. And furthest. I don't know, where do they look like they're the furthest? Could it be year 16? 1, 2, 3, 4, 5, more than 5 percentage points? Or what about the other one? Let's see. That's about what, 1, 2, 3, 4. Actually, it looks like 16 is a little bit further away than in year 1. I'm going to go ahead and choose 16. But apparently wait a minute. Oh, hold on. Wait a second. What do y'all think? How about year 3? 1, 2, 3, 4, 5. Well, year 3 might be a little, actually, that might be a little bit more. Wow, I guess I should have looked a little bit closer. 1, 2, 3, 4. Sometimes when I try to do these faster, I end up making a mistake. What do you guys think? 1, 2, 3, 4, 5. Oh, wow, 13 could be also. Angela, you think 15? Yeah, 15 might work. I have to. Now, I guess what I should do, okay, to do this a little bit more carefully is probably expand it. When let me go ahead and show you that. If you go ahead and click on the little magnifying glass, you can go ahead and make it look bigger. And that's probably what I should have done, just so I can see the differences between them. And yeah, 15 looks a little below, a little above. Yeah, 15's further than 16 that I put because I didn't look at it carefully. Yeah, 3, not so much. And 2, yeah, you know what? I think you're right. I think I like your suggestion, Angela, of 15. Let's go ahead and do that one. All right, very good. And then now, Ian, your question. Part E. Okay. The misery index is defined as the sum of the employment rate and inflation rate. So I guess misery index, okay, you've got those two things. If unemployment rate is high and inflation is high, when you add those two, that's the misery index. That's how unhappy we are, I guess. So it says, according to the misery index, which year was more miserable, 17 or 19? So we have to look carefully to see which has a higher sum. So it looks like 17 is about what, 3.5 plus 8, that would be about 11.5. 19 would be, well, that's not quite 3.5. Let's call that 3.3 and maybe 6.3. Now that's not going to get us close to the 11.5 that we just figured out for year 17. So I would say that year 17 is probably about 11.5%. Now, if you give a reasonable guess on this, I'll tell you, if I'll say 11.5. Now, if you give a reasonable guess and it like I'm going to do, and if it tells me wrong, okay, it's not a problem. If you get something wrong and you think it's right, take a picture, send it to me. I can give you credit. My lab does not determine your grade. My lab just helps. And so if there's any time where you think you got it right and it's marking you wrong, take a screenshot, send it to me, and we can figure it out. All right, so we'll see if 11.5. Okay, and for 19, oh, what did we say it was approximately for the 19? I would say maybe 3.3 for the 19 plus about 6.3, 9.6. I'll just say 9.5. Go to the nearest half, 9.5. And if it doesn't like that, then I'm not going to worry about it. So 17 was more miserable. Let's see what it says. Hey, all right. It liked my approximations there. So, Ian, is that okay? Yeah, you just have to take some good guesses. And it does say, integers, decimals rounded to 1 decimal place. So sometimes the directions, we got to keep an eye on the directions. Is that all right? Any other questions on 2.3?
I had a question for question 3 on 2.3.
Great. Okay, let's take a look at that. All right. It says the accompanying frequency polygon represents the number of countries' residents below 100 years of age, complete A through F. So any particular part, you got to click on the data to look at it. Oh, I see. Yeah, this is a common question. Now I'm seeing what's happening here. Let's take a look. All right. Now, remember that all of these points are midpoints. Now, the class width is going to be the same. So we can look at, okay, the distance between these midpoints is 10. So the class width would be 10. That is okay. Usually what happens is when people want to know like the class limits, then it's kind of funky. Okay, there are there are blank classes represented in this class, in this graph. And so the classes, remember those, like for example, if I, let me make just kind of a little diagram. Like for example, if you've got 5, okay, that's the middle of one of the bars. And so that's gonna have a bar between, let's say, if that's the middle, and then the next middle is 15. So halfway in between, there is 10. So we're going to have, like, for example, the first bar is going to go from 0 to 10, and then the next bar is going to go from 10 to 20. You know, maybe like that. I'm just kind of doing some basic diagrams just so you can get an idea of what I'm talking about. Okay, so let's see. So how many classes are there? We'd be thinking about how many bars are there. Now remember, I wouldn't count the dots on both ends, because in a frequency polygon, you just have dots that go down to the end. The end dots do not represent data. So as far as classes, I'm thinking there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is what I'm going to say. We'll see what my lab has to say about that. All right. Then it says, what is the midpoint of the first class? And then what are the upper and lower limits of the first class? Now, assume that gives you a little hint that assume that the upper and lower limits are whole numbers. Okay, so the first class, the midpoint of the first class, that's the 5. And I just circled that right there in my green crayon. Okay, and then now the limits. This is a little bit of a kind of a trick question, but I did address this in the lecture last time. So let's put in midpoint first. And then what's the lower limit of the first class? The first class goes from 0 and not to 10. Okay, 10 is the start of the next lower limit, the next class. So we would say 0 to 9. Okay, and they did say do whole numbers. That was a little bit of a hint right there. So the lower limit is 0. And then the upper limit of the first class would be 9. Okay, usually that's a little bit of a bit of confusion. Okay, and then so then you get some other parts. Now, what is the midpoint of the next to the last class? And so is that okay? Did that take care of your question? Usually it's on those class limits.
Yeah.
Yeah, okay. Now, again, if after today, after we've had this conversation, you're like, oh man, that was holding me up. I didn't get a chance to get my 100%. Again, stick around after class. I'll go ahead and do some extensions, and then and then you can get your 100%, because that should be your goal. you get the 100% on your homework, that'll help your grade. And of course, we got quizzes and tests and everything else, but certainly striving for the 100%. Everyone should strive for the best homework score. Any other questions on section 2.3? Are we good? Not seeing any others come up. Let's go ahead and go to 2.4. Now in 2.4, we talked about the misuse of statistics, and that's kind of the fun side of statistics. Actually, I didn't write any notes on that, so let me bring up the PowerPoint. Some of the misuses of statistics, and what's interesting is there are so many examples in the outside world of misrepresenting statistics. The only two we focused on are, certainly the disappearing zero, which is what you see in the graphic right there on the PowerPoint, and then just a deceptive graph or a deceptive scale. But, I was talking to a friend of mine since our last class, and he's a lot of fun to talk to. He's actually an attorney, and he deals with statistics and science and all kinds of things. And so he actually gave me this example that actually this story, I don't know if y'all have ever heard that that eating chocolate helps weight loss. Okay, that was all a scam. Okay, and I have this article right here in my phone, and where it says, "I fooled millions into thinking that chocolate helps weight loss. Here's how." All right, and so maybe I'll talk about how that was done sometime. But the whole point of what I'm saying right now is that statistics can be very deceptive. And so you really have to ask the questions of where is the data coming from and what are they saying? Because, another example, I read a study that said that amusement park roller coasters are safe. Okay, well, that sounds nice if the numbers say so. But the thing is that this study was published by Six Flags. Okay, Six Flags, they own Magic Mountain and a bunch of other amusement parks across the country. And so, of course, they're going to say that amusement parks are safe. Okay, again, so sometimes, the data, where does it come from? Who is it serving? Those are all things we need to ask whenever we see a headline. And I'm going to be talking more about this. One of the questions that I'm going to give you to answer more in the future, okay, has to do with like popularity of the president and things like that, and looking at some of those statistics. And that came from an actual article that that's going to be part of a lab assignment. That's again in a month. And so but we'll be talking about some of the use and misuse of statistics and actually crunching the numbers and deciding, is this, well, misrepresentation or not. So 2.4 was kind of fun, and it was pretty short. So anybody have any questions on that? Are we good? All right, not seeing any questions there. So let me go ahead and go to chapter 3. Now, chapter 3 is where we really started getting into statistics, okay, or the math. Okay, so I'm going to put some things here, some key notes for today. Now, what I have here, okay, anything that's in red, that's an important concept for this class. And so what we have here is what I put it in quotes, I'm quoting myself, okay? I'm telling you, I kind of made that up, but because that's what it is. It's what we have is, whenever we describe a set of data, we have 3 main characteristics that we look at. We look at, well, what's the shape of the histogram? That tells us the shape of the distribution. It could be uniform, bell-shaped, skewed right, or skewed left. And so then that's what we already talked about in chapter 2. Then chapter 3, we talk about the measures of center. Okay, so the main measures of center that you want to be concerned with and understand are the mean, median, and mode. Okay, and we talked about all three of those things, of course. Now, with any statistic, any number that we deal with in this class, we can have a population. Does it represent the population? Or does it represent a sample? And so we have symbols that tell people, are we representing a population, the whole group, or are we representing a sample? So you can see right there, I circled the Greek letter mu and the X bar, okay, and how to calculate the mean. Then the median. The median is the middle value. So I talked about how to find the median. And then one of the special things, the difference between the median and the mean, is that the median is resistant. It's unaffected by extreme values. So anytime we have data with extreme values, extremely high or extremely low values, we often use the median. And I gave a couple of examples like housing prices in Orange County or annual income in Orange County. There's quite a wide range. There are people that make millions and millions and millions of dollars, and there are people that don't. I'm one of the people that don't. But anyway, so mean and median are really important to know and understand. We use those a lot in the outside world. And then the mode is the most common. Okay, occasionally you see the mode used. Often it's for categorical data that you can't find a mean and a median for. You know, you're just looking at the most common occurrence. And so, but that's knowing those three things. Now, StatCrunch will calculate the mean for you. So hopefully when you did this homework, you used StatCrunch. You don't need to use your calculator. StatCrunch is available along the left side. And you can see right there, I'm going to go ahead and open it up. And then go to StatCrunch website. And then you can use StatCrunch. Open StatCrunch right there. Now, you can use StatCrunch. You can put data in manually. Now, what you can also do is when you're doing the exercises, oops, let me go back to exercises, like say, for example, okay, whoops, yeah, I left the course. Hold on. All right. When you're doing the homework, and if they give you a set of data, there's usually a little icon that you can click on. And let's see where we are. It's running a little slow, but there's a little icon where you can open up the data. So you won't have to do much as far as putting data into StatCrunch. StatCrunch does a lot of neat things for us. And we're going to be doing some StatCrunch today. And I'll be giving you a chance to practice with it. So again, if you let your MyLab access expire, you can't take the quiz today and you won't be able to practice StatCrunch. So that needs to be taken care of, should have been taken care of yesterday. All right. So let me just pull a problem, 3.1, and I'll show you, unless anybody has any questions on any of them, but I figured I would say a few things about StatCrunch here. So let's see, I'm just going to go into the problems right here. Oh, let's see. We have a It says find the population mean or the sample mean. Well, it says for the sample. So when it tells you it's a sample, it's going to be a sample mean. The calculations are the same. Now look at this little icon right here. See that right next to the data? If you click on that, it'll say open in StatCrunch, copy to the clipboard, or open in Excel. We can go ahead and choose open in StatCrunch. And look at that, the data is right there. And so what we did last time, it's stat, summary stats, the first column, then we click on the first column, hit compute, and the mean is right there. The sample mean is 12. Okay, so that's as easy as it's going to get. We're going to go ahead. We can use StatCrunch. It works very well with MyLab. We do not need to enter. We rarely need to enter the data. Usually you click on that icon and you're good to go. So I'm just going to go ahead and put 12 for the sample mean. And there we are. Okay. So anybody have any questions? Let me take a look at my notes. You look at your notes to see if you have any questions. I'm going to look at my notes to see if I forgot anything. Okay, mean, median, and mode. Yep, that's pretty much it. There is a nice summary screen I have in the PowerPoint. It's toward the end of the section right there, and it talks about the 3 measures of center that we have, how to calculate them, and what it means, okay, and when to use, okay, and it even says here that when data are quantitative and the frequency distribution is skewed left or skewed right. So again, if you have extremely high or extremely low values, it's skewed, and then that's when you want to use a median. All right. Is everybody okay with that? Everybody okay with using StatCrunch? I get to use StatCrunch in the next section also when we do standard deviation. So let's see. I'm not seeing anything in the chat. Am I? Yes, I am. I see myself moving. So I know I'm not frozen up. So people are quiet today. Having trouble waking up? Yeah, no? All right. Last call. All right. Well, then let's go ahead and go on to section 3.2. Now, remember, in 3.2, let me close this assignment. Okay. And in 3.2, we talked about the measures of spread. Now, the 3 measures of spread that you want to be familiar with are the range. So 3.2, the measures of spread. There's the range, the standard deviation, and the variance. Now, again, StatCrunch will do the heavy calculations for us. So what you need to know is certainly what they are, what they mean, and how to get them in StatCrunch. And so you can see I highlighted them right there, right in the beginning. And then range is the largest minus the smallest. And then the standard deviation has, you know, a little bit of a formula to it. And again, StatCrunch takes care of that for us. But just remember that for these, again, we have a population standard deviation and a sample standard deviation. And both of those have different formulas. The formulas are slightly different. So you have to know, am I dealing with a sample or am I dealing with the population, the whole group? All right. And again, StatCrunch will take care of that for us. Now, as far as the variance is equal to a standard deviation squared. Okay, and that's also right here. I showed that and the symbols. Now, we can look at it as the variance is the standard deviation squared, or we can say that the standard deviation is equal to the square root of the variance. Same thing. All right, and so you can see the symbols there. Then, and again, we used Stack Crunch, and when you're given a set of data, there will be that little icon to load it into Stack Crunch. And I think, I think I still have Stack Crunch with that data. Yeah, and you can see that this standard deviation, this is Stack Crunch automatically gives you a sample standard deviation. 99% of the time we're calculating a standard, a sample, excuse me, sample standard deviation. If you want to do population, the population standard deviation is you got to go under options and edit, and then you have to choose the unadjusted standard deviation. Okay, that's what Stack Crunch is calling the population standard deviation. That's the unadjusted. But there might be just one problem where you need population, and I talked about that last time. So that should actually be in our notes. Let me look in the notes from last time. Let's see, we talked about mean, yeah, Stack Crunch, median, range. Yeah, I talked about all kinds of all those things. Okay. Yeah. So I guess the note to self, as far as population standard deviation, if you're talking about a population in Stack Crunch, that's the unadjusted standard deviation. All right, but again, most of the time we need this, we use the sample standard deviation because most of the time we're dealing with the sample. So yeah. All right, any questions there on 3.2? No questions? Want a quiz? Oh, can you explain? Okay, Ruby got right in there. Usually if I ask if anybody want a quiz, then that usually inspires some questions. So let's go ahead and take a look at number 9. What's going on with now? Actually, I just realized I did not finish actually the summary of 3.2. And number 9 might involve something else. Let me look at number 9 first, because the other thing that I wanted you to be familiar with is the empirical rule. So let me see if 3.2 deals with empirical rule. If it does, I'll say a few words about that first. All right, number 9. Okay, yes, 9 is empirical rule. So I'll tell you what, Ruby, let me explain that, and I will come back to your question. All right, so let's look at, now again, the here we got the PowerPoint, then the actually the notes from last time, I did take a look at that. Now, remember that, well, let me bring up the PowerPoint too, because I got things I got to say on both of them. So let's put the PowerPoint over here. And then now, this slide is important. This is how we use a standard deviation. And it says right here, it says the standard deviation is a unit of measure that's used to measure how far a value is from the mean. Okay, and we're going to be talking more about that today. So this is kind of an important topic as far as understanding what a standard deviation is for and how we use it. So what I did is last time I talked about, okay, if you've got IQ scores where your mean is 100 and a standard deviation of 15, I gave some examples of just various scores and then saying like 115 would be one standard deviation above the mean and 130 and so on and so forth, so that we're used to talking about number of standard deviations from the mean. So what that does, and then that leads us to this thing called the empirical rule. If we understand how we're using the standard deviation, then the empirical rule doesn't seem so crazy. Now, there are three pieces to the empirical rule, and you can see them right here, is that for the data that's within one standard deviation, we expect about 68% of the data. Then within two standard deviations, we expect about 95%. And within three standard deviations, we expect 99.7% of the data to fall within three standard deviations. Now, in case you're wondering, wait a minute, Mr. Zarski, where did you get those percentages, that 68%, 95%, and 99.7%? That I got to tell you later. Okay, we will explore that later. I will tell you where those percentages came from. That is in a chapter called the normal distribution, the bell-shaped distribution. I can't tell you everything at once. That just is a mind-blowing experience. I got to save some stuff for later. So we're going to be talking about that in a few weeks. So for right now, what you want to do is, again, be familiar with these three numbers, the 68%, the 95%, and the 99.7%. So now let's go ahead and let me bring that problem up and my whiteboard, and we'll look at it. Okay, so here's the problem and notes. Okay, so this is now 3.2, number 9. Okay, so it says an IQ test has a bell shape. Oh, this is very similar to the example I had. Now, in this case, it says the mean is 100 and the standard deviation is 19. Okay, so now it says what percentage of people have an IQ score between 43 and 157? So 43 to 157. Now, the thing is just how many 19s, if we have 100 right here in the middle, how many 19s are there to 157? Well, it turns out if you look at, that's 3. 19 times 3 is 57. 19 times 3 is equal to 57. So we would say that 157 is 3 standard deviations above the mean. I'll say 3 SDs above the mean. And the same is true with 43, because it is 57 below 100. So it is 3 standard deviations below. Okay. So with that, then if we go back to, remember those 3 key numbers here for the empirical rule, what we expect, 3 standard deviations above and below, that would be 99.7%. So we put in 99.7. Okay, so what you need to do is figure out, are we talking about 3 standard deviations from the mean, 2, or 1? There are only 3 parts to the empirical rule. And so at this point, that's what we're concerned with. We need to look at, okay, in each problem, is it 1, 2, or 3 standard deviations above or below the mean? So let's look at part B. Part B says, what percentage of the people has an IQ score less than 62? Ooh, now that's an interesting question. You have to get creative on this one. Let's see, if 100 is in the middle and 62 and 138. Now, 138, okay, that's 38 above the mean. That's 2 times 19. 19 times 2 is 38. So we would say that that 138 is 2 standard deviations above. And similarly, 62 is 2 standard deviations below. And what that means, if we remember the empirical rule, is that 95% of the data is between those two values. Okay, so now what it's asking, how much is less than 62 and greater than 138? So then the question is, what's the leftover percent? Okay, remember that for all of our data, we've got 100%. 100% is everything, the whole thing. So if we've got 95% in between, that means that 5% is left over. A little bit creative there. Yeah, I gotta do a little thinking. So that's 5%. Okay. And then what percentage of people has an IQ score greater than 138? Well, greater than 138, that's asking for just the upper tail right here that I just shaded. And oh, I see a question come in from Mariana. Will the standard deviation always be the same? Yes. Okay, it's the same for the whole problem. So the standard deviation will be 19 throughout the problem, if that's what you're thinking. Always be the same, like on one side we have 2 standard, the other side automatic. Not always. Okay, now that's an interesting question. Will it always, for this section? Yes, it should be the same. If it's not, well, then we're going to have to get creative again. But most of these problems should be the same. But you'll notice that I did check just to make sure that I kind of checked mathematically that the 138, that was plus 38 above the mean. And then if you take 100 minus 38, that's 62. So that's 2 of the 19s above and below. But if it's a little bit different, then what we would have to do is, I'm going to refer you to a picture. I'm not going to give you those, well, at least quite yet. We got to talk about that. It's going to come up today. But if it is different, then we'd be looking more at kind of using this picture right here that I have here in the PowerPoint. Okay, but let me go ahead and finish this problem, and I can explain your question a little bit more if you want. Let's see, what percentage of the people? Oh yeah, so that's the green area. Now, one thing about the bell-shaped distribution or the normal distribution is we say that it is, and I'm going to put this in red, that we say that it is symmetric. And the word symmetric means the same on both sides. So the thing is if the total amount was 5%, then what we're going to be looking at for that tail that I shaded in green that they're asking about, we would say that it's half of the 5%, or it would be 2.5%. Okay, so that's what I'm going to put into here. It's 2.5%. We got to get a little creative. That was a great question, Ruby. Did that answer your question? Is that okay?
Yeah, so is it always going to be the half of, whatever number is in the 138? Is it always going to be half of the 5?
Well, yes, if that's it, because it's symmetric. If they ask you, I mean, they could ask you a few different types of questions here. If, again, the part B was a total, I shaded both tails, that was the leftover was 5%. And so then if they ask you one of those pieces, then it would be half. Yeah. Okay. Now understand, they could ask you, okay, let's change the question a little bit. We'll use this same one. So suppose that they said maybe what percentage is between, let's say, 81 to 119. Now, 81, okay, if 100 is in the middle, 81, where is that? And 119. Well, 119 is plus 1 standard deviation above. 81 is minus 1, that's 1 standard deviation below. And so if it asks, well, what percentage is between there? Well, we would say 68%. But then what if it asked you, well, what percentage is below 81 and above 119? If it asks for both, then that total, well, let's see, what's left over from 68%? That's 32%. And if it asks for one of them, well, it'll be half of that. One of these is 16%. Okay. So the main thing to keep in mind is the three things, of course, there's the three numbers, the 68%, the 95%, and the 99%, 99.7%. And then, of course, that the curve is symmetric, which means it has the same on both sides. So you might have to do a little bit of thinking, a little bit of math to answer some of these questions. Yeah. And like I say, Ariana, I want to get back to your question. Just for everybody, I'll read the whole thing. It'll say, will the standard deviation always be the same? Like one side we have 2 standard deviations, will the other side automatically be 2 standard deviations? And that's where I'll say most of the time, yes. But if not, let's do another example. Suppose we're looking at 81 to 138. Okay. Now, if we're looking at 81 to 138, 100 in the middle, 81, 138. Now, 81, like we said, is 1 standard deviation below, so I'll say minus 1 SD. 138 is 2 standard deviations above, so I'll say plus 2 standard deviations. Now, this is where, again, I'm not going to ask you this on a test or a quiz, not yet. That's a little later in the course. Because in order to answer this, you'd pretty much have to kind of memorize this chart and understand that a little bit more. Now, if you look at this diagram, you can see that like the 68% and is 34 on one side and 34 on the other. So it's divided in half. That's the symmetry part of the curve. So if we were going to do this, we would have to do a little bit of math. Again, for 1 standard deviation below, you'd be looking at the, well, 34% for that little piece. And then for 2 standard deviations above, you've got one piece, which is 34%. And then the next piece, you can see right there, says 13.5%. And you'd have to add all those up to answer the question. So could you get that in the homework? Well, you could. And yeah, again, I would suggest using this diagram that's got all the pieces. But again, I'm not going to get that far into the weeds. Any questions that I ask you as far as the empirical rule, at least on a test or a quiz, will have 2 standard deviations above, or, have the same thing above and below. All right. So I hope that answers your question, Ariana. If it doesn't, well, ask again. Let me know. All right. So anybody have any questions? Anything else? All right, well, I'll tell you what, let's go ahead and have a quiz. Now, I'm going to have to take a moment and adjust. Now, don't click on quizzes and tests yet. All right, I need to change the adjustments. So don't go there yet. Wait one moment. This is quiz number 2. Because I don't know exactly what time we're going to start the quiz and things. So let's see, it logged me out. So like I was saying, because I don't know exactly what time, I put in kind of a general time in my lab, and then when we actually start it, that's when those settings, let me change the settings. Let's see. So I will say that I'll call it 9:20. So then, and then you're going to have 20 minutes for the quiz. So if we call our official start time 9:20, then we're going to, it'll be due by 9:40, and then we will take a break. So again, now don't click on it yet. I'll tell you the password in just a moment. I need the changes to take effect. There were a couple of people that had trouble, didn't get enough time, and I suspect it was because you didn't refresh the screen for the quiz. So now remember, of course, that when we take a quiz and or a test, that we do need to show live video. That is required. Otherwise, you'll get a 0 for the quiz. So you have to have live video. And if you have any questions for me, chat me individually. Okay, we don't need to bother the class. I'll be watching my chat. Again, you find me at John Zarski host. That's the chat I will be watching. So the official quiz time will say 9:20 to 9:40, and then we will take a break from 9:40 to 9:50. So that's the time to come back. Okay, so now you can go ahead and click on assignments or click on quizzes and tests along the left side of My Lab. And you can go ahead and get going on the quiz. The password for today is median. 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 Okay, so good luck, and chat me if you have any questions. Okay, so well, let's go ahead and continue on. Hopefully you had a nice break. I did. I heated up my coffee and took a little walk around. And so let's go ahead and continue on. Now again, let me just take a quick look at, hold on. I want to bring up on Canvas, on the syllabus, just the schedule as far as where we are in the semester and what's happening. Okay, you can see right here, we're on the 24th. So what we have right now is we've got 5 sections to talk about. I know that that's really ambitious, but what's really nice, again, is that StatCrunch does a lot of the heavy lifting for us. And so we can just concentrate on the numbers, how to use StatCrunch, and what it means. So this is definitely doable in the next 2 hours. And then I'm going to save a little bit of time just to give a little recap of and talk about the exam, because we've got, look at that, an exam next week. So I'm going to talk about what that will look like. And so we've got a lot to talk about here today. So let's go ahead and get on with chapter 3. Now, you would have done the, again, done the media assignments. Now on this one, again, this is one of those sections that is ugly to do the calculations if you do them by hand, or even with a calculator. I mean, it's just really kind of an ugly calculation. So that's where using StatCrunch really does the heavy lifting for us here in this section. And so again, let me write that down. 3.3 is we are going to use StatCrunch for when we're talking about mean and standard deviation of grouped data. Okay, that's all StatCrunch. Then we're going to talk about that weighted mean right there. And that's a little different, but you can do that with a calculator pretty easily. And the weighted mean, I'll highlight that right there. That is that's a nice little thing to know how to do, because especially if you, as students, if you ever wanted to calculate your grade point average, because different classes have different unit values, they get different weights. So not all classes are created equal. So we're going to talk about that a little bit later. But let's talk about right now, what we're going to do is I'm going to talk about the grouped data, and you've got mean and standard deviation. So I'm going to talk about those together, and what group data means, and then how to use StatCrunch for those. So let's talk about what do we mean by grouped data? Well, grouped data is, let's say if I have an example right here, when you have frequency data, or like a frequency distribution. When you have a frequency distribution, you're going to have the classes, okay? Like here in this example, it says, well, National Survey of Student Engagement is a survey that, among other things, asked first-year students at liberal arts colleges how much time they spend preparing for class each week. And so you can see the hours 0 to 5 and all of those. You can see again, we have class limits. And that's all we have. All we know is we know that there were 130 values from 1 to 5. And we have 250 values from 6 to 10. And 230 values from 11 to 15. But we don't have the original data set. And so the thing is, that's the problem. Okay, so when we have grouped data, that means we don't have the original data set. All we have is, well, group data. So you can even see this question that I put at the bottom. How do we calculate the mean if we don't know the original data set? And so what we do is, well, we have these these look like ugly formulas. Okay. And again, StatCrunch takes care of this for us. But the gist or the thinking behind this is we basically, what happens, you'll see that we use the midpoint. Now I'll highlight that, see that X value, that's the midpoint. And then we look at how many of we have. And so the idea here is we pretty much pretend that all the data values are midpoints. We pretend all data values are midpoints. And that's the best guess we can have. If we just take the midpoint of each class, and say, okay, that's our data point. Then we calculate the mean and standard deviation based off of that. Now, what I told you about midpoints, again, you won't have to do that because StatCrunch, again, will do that for you. And so, let's say, for example, if we take a look at this data, okay, that's the same data. You can see it right there. You have to calculate the midpoints and then how many there are in each class. Now, I'm going to go ahead and put that in. Now, remember that when you're doing StatCrunch, you just hit the little icon and then you're good to go. So I'm going to go ahead, take a moment and put this data in. So in var1, what I'm going to put in are those frequencies. So I'm going to ignore the first one because they're just zeros. So 455, 2125, 3105, 3330, 2350. Again, you won't have to do this because, well, the data, you can just load it straight into StatCrunch. 1710, 1675. Okay. And then we need the midpoints. Now, the midpoints were already calculated. Now, what they did to calculate the midpoints is they found the middle between two lower limits. Because of this mathematical gap, you can see like the first class ends at 5, the next one starts at 6. To find the midpoint, what they did is they went 1 plus 6 over 2 and got 3.5. So in case you're wondering where that midpoint came from. So 3.5. And then 8.5, 13.5, 18.5, 23.5, 28.5, and 33.5. Okay. And so then what we're going to do is we're going to go up to summary stats. But in this case, we've got grouped data. So notice right there, we have grouped data. I'm going to choose that grouped data. And then now we've got, they've got these two things of bins and, let me expand this a little bit. We've got bins and counts. Now the counts, that's the how many. Okay, that's the easy one. That's in var1. The bins, those are your midpoints. That's in var2. All right. And then we're going to go ahead and then you hit compute. And then we get the mean and standard deviation. Now, let me go ahead and make that a little smaller. You can see what the mean is. Wait a minute. What's going on? Hold on a minute. That's not looking like the same answer. Did I make a mistake in putting in the what is going on? Let's see, 455, 2125, 3105, 3330, 2350, 1710, 1675, 3.5, 8.5, 13.5, 23, 28, 33. Huh. Just a second. There's the group data. That's bid points. Now, wait a minute. Now, we should be okay on the limits right here, but maybe that's it. Maybe I should have chosen consecutive lower limits because that's how we did calculate the midpoints. Now the mean here should be 14.75. Okay, now I've done this before. This is now very strange. I've done this before, and the numbers come out to be the same. Now, what we should have is, you see the mean here. Okay, I'm running into technical difficulties for some reason. The mean should be 14.75. And the standard deviation I have a little bit further on, and it should be 8.1. Why that is not happening this semester, I am baffled, because it should just be the limits. That says a mean of 19.2. Let's see, I did. Wow. Oh, hold on a second.
I had a comment.
Yeah, Jasmine, what's up?
For the media, when I went over the medias, when it displayed the information on StatCrunch, it used two columns, one for the classes, the class intervals, and then the second one for the frequencies, and they did they computed the results based on those two.
Yes, no, that's right. I just noticed what was wrong. I put the wrong data in for Ver 1. Look at that. I put 455, and those weren't the frequencies. That's the midpoint times the frequency. That's what it says. The frequencies are right here. My eyes were looking in the wrong column. So that's it. I mean, so that sounds like what you were saying. You said they use the frequencies. I meant to use the frequencies. I was just using, again, the wrong column. So 250, 230 are the frequencies, 180. So again, and this is the data that you would get. See, if you go back to the original set of data, let me show you on the table right there in the PowerPoint, those are the values. You can see the 130, 250, 230, 180, and then 100. Oops. Okay, 100. And then 60. Whoops. Okay, there we go. So then, of course, we're going to go back and everything should be okay. There we go. All right. Silly things. Anyway, okay. So you can see there we get the mean of 14.75, and then the standard deviation you can see is 8.1. Now, but you bring up a good point. And now what I did is I just went ahead and used limits, okay, because I just put in the midpoints themselves. Now, if you don't, if they load the data and then they have the classes, then you'll probably want to choose, you'll have to tell it to use consecutive lower limits. All right, so take a look at the data that you have and understand that you might have to define how the midpoints were defined here. And so, oh, Liliana, it looks like you said lower C wasn't pressed. Oh, I see. Yeah, the consecutive lower limits. Now, what would be interesting is to see, because I put in the midpoints myself. Yeah, see, that changes things slightly. Yeah. So I'm actually using limits, not because I computed them myself. Now in your homework, it might be showing you like 1 to 5 in one column and 6 to 10 in the other. And then you might need to define how to calculate the how they calculate if they use consecutive lower limits. All right, so that's pretty much, go ahead and play with that and practice using StatCrunch. And again, if you have any questions, feel free to send me an email, or again, see me during some of my virtual office hours. Now, what I want to do is take a moment and now go back and look at the weighted mean. Now, the weighted mean, again, is kind of cool. And I don't know if you think of that any of this stuff is cool, but for a weighted mean, all right, and you see here it says a weighted mean of a variable is found by multiplying each value of a variable by its corresponding weight and adding these products. Okay, it tells you how to do it. The reason you would calculate a weighted mean is because sometimes we have data where some numbers are more important than others, or where some numbers, let's write that down, where some, maybe I'll use the term value, maybe some numbers carry more value or weight. Okay, so the idea of a weight is the value of it. So to help wrap our head around this, I mentioned earlier that doing a your grade point average is how it's calculated. So if you were to look at your transcript, your school transcript, and you wanted to and you looked at your grade point average, this is actually how it's calculated. And so that's what's kind of neat about this problem, because it does actually get used in the real world. So let's say, for example, okay, I'm going to ask you, well, what's your GPA? And let's suppose you have a 3-unit A and a 3-unit B and a 4-unit C at the end of the semester. So again, now the unit values of the class, that carries more weight, you know, so a 1-unit PE class is not going to be counted the same as, let's say, a 4-unit statistics class. You know, what you learned before, like in high school, okay, yeah, an A is worth 4 points and a B is worth 3 points and a C is worth 2 points. And if you were just going to average those, 4 plus 3 plus 2, you would get 9/3, which would be a 3.0. That's in high school, but not college. Okay, in college, we've got to take into account the unit values, and those are the weights or the values. And so what we do, you see in this formula, to calculate your GPA or the average, what we would do is it says you take the value of each variable times its weight. So in this case, we have an A is worth 4 and its weight is 3. A B is worth 3 and its weight is also 3. And then a C is worth 2. And then because it's a 4-unit C, that's the weight. And then what you do is you add up all of the weights. So that would be 3 plus 3 plus 4. Okay. And if you do a little bit of math on that, you would get 2.9. Okay. And so you can see what's happened is that 4-unit C carried more weight. And so it kind of dragged the it dragged the GPA down just a little bit. Okay, so that is the weighted mean. You don't need to memorize this formula. And, you know, you have one or two problems in the homework where you calculate the weighted mean. And again, the weights, if we're going to color code this a little bit, you've got the weights, the 3, 3, and the 4. Those are right there, 3, 3, and the 4. And then the values in the GPA, like what an A is worth, the 4, 3, and 2. That's right there. Oh yeah, and then your weights are on the bottom. Okay, and then you do a little bit of math. So yeah, the homework problems won't be too complicated or tedious. You can go ahead and just put those into a calculator and you will be okay. All right, any questions there? And if there aren't any, let's go ahead and go on to section 3.4. 3.3 is a relatively short section. In 3.4, they talk about measures of position. Okay, and in case you're wondering, well, what is that? It's a measure of position within the group of data. Like, you got all this data, where are you in the data? And so we have two main measures of position here. There's a z-score and then a percentile. So those are the two types of measures of position that we will take a look at. So the first one we will look at, and I'm going to put this in red because it is a very important thing, and that is a z-score. All right. So, and you can see right here on the slide right there, it tells you what a z-score is. And notice I did put that in red. It says a z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. Now, if you're thinking, wait a minute, Mr. Zarsky, weren't we talking about number of standard deviations from the mean? Well, last time, and we kind of reviewed it today. Yeah. Okay, there's this z-score formula you see right there. Now, just a moment. Okay, let's just kind of recall just for a moment. So recall. Okay, remember when we talked about IQ scores? And the example that I did, I said that the mean is 100 and the standard deviation is 15. And then remember, I had various examples of values, like say, for example, if you had a score of 130, we said was 2 standard deviations from the mean. Okay, we said that 2 standard deviations above the mean. Now, the thing is that I used 130 because that was kind of, the math was nice and it worked out nice. But we've got this z-score formula. Okay, right there. It's basically the same thing whether you're dealing with a population or a sample. What you do is you take the value you want, in this case 130, subtract the mean, which is 100, and then divide by the standard deviation. And if you do that, you get 2. Okay, and that 2 is the number of standard deviations from the mean. That's what that means. So that's why I put it in red, because that's important to know what a z-score is. We're going to see lots of z-scores in the future. So it's not just now, it's later too. All right, so we need to understand what a z-score means. So now, let's do one more of these. Suppose we had, remember when we were talking about IQ scores, I had an example of 45. And I said that 45 was 3 standard deviations below the mean. And if I go ahead and use the z-score formula on this, 45 minus the mean divided by the standard deviation, we would get -3. And again, that negative says that we are below the mean. So that z-score formula is kind of cool. Now, you'll have some homework problems asking about z-scores. Now, one thing a z-score is a standard score. Sometimes we call that it's a standard score. And let's go ahead and write what it's good for. I mean, it's good for a couple of things, but in the homework, it's going to come up where it's good for comparing two different groups. Let's write that down. Good for comparing two different groups. My writing's kind of messy right there, but now where I'm gonna go to the book, and we're gonna go to the book on page 160. So let me bring up the book. It might have logged me out, but well, let's see. I've got the book right here, page 160. Okay, so you can see right here, there are the z-scores, and you look at this example right here, and you see we've got two different things. Let's go ahead and read it. It says, determine whether the Boston Red Sox or the Los Angeles Dodgers had a relatively better run-producing season. The Red Sox scored 876 runs and play in the American League, where the mean number of runs scored is 731.2 and the standard deviation was 72.6. The Dodgers scored 804 runs and play in the National League, where the mean number of runs scored was 710.8 and a standard deviation of 660.2. So now we've seen the data. Now going back to the first sentence, it says determine which whether the Boston Red Sox or the LA Dodgers had a relatively better run producing season. Okay, we've got two different groups, two different numbers, two different means, and two different standard deviations. So it might seem like apples and oranges. Okay, but if we do this z-score, again, it's a standard score of how many standard deviations it is from the mean. That allows us to compare both of those. And you can see right here that they calculated a z-score for the Red Sox as 1.99 and then the Dodgers as 1.55. So because the Red Sox is more standard deviations from the mean, we would say that, well, they had a higher number of runs. And so you can even see that it says there. So the Red Sox had a run production of 1.99 standard deviations above the mean, while the Dodgers had run production of 1.55 standard deviations above the mean. So therefore the Red Sox had a relatively better score. Okay, when they're looking at within the group. Again, this is a measure of position or measure of relative standing. And so when you're looking at relative to their group, the Red Sox did better in the American League as compared to the Dodgers in their group who are in the National League. So you'll get a couple of homework problems where you'll get to compare groups and compare relative scores, and you go ahead and calculate a z-score. So anybody have any questions on z-scores so far? Questions, thoughts, comments? Yes, no, maybe?
I have a question that
Yes.
the z-score can be a decimal.
Yes, yes. Can be
So,
decimals, definitely can be decimals. Usually we round to 2 decimals. When we do more z-scores, we're going to see lots of z-scores, not only here in this unit, but when we get to chapter 6. And yeah, definitely decimals are okay.
can you come back to the example of the whiteboard?
Yeah. Right there, or the PowerPoint. Let's see.
The example, can you
Which example?
can you roll down?
Scroll up right here.
Yeah. The z-score that is -3, but maybe that will be -3.66, right?
Well, yes, if it were not 40, if we put 45 into our calculator, we get -3. But if it were, let's say 40, then yes, we would get a decimal. It could be something like -3.6 or 3.8, or, you know, we can get all kinds of different numbers, but yes, decimals are okay. I just chose these because remember from our notes last time, and I'll bring those up. Remember, these were numbers that I gave as examples when we were talking about number of standard deviations above. Oh, hold on. Wait a minute. Did you catch a mistake? Is that what you're saying, 3.6? Hold on a second. Who was it? Who just asked the question? I didn't catch the name.
Me, Tweet.
Tweet.
Yeah.
Tweet. Yes, hold on a second. You might have earned yourself an extra credit point. 1 second, look at that. And I'm going to highlight it in green right here. Look at that. I did 45. And what was my example before? Look at that. Again, looking at the notes from last time. Wow, I haven't given an extra credit point for a little while. Look at that. What did I do? I did 55. Now, hold on a second. Let me correct that. Tweet, I am going to give you an extra credit point right now because you caught that. Now, extra credit points. If you catch a mathematical mistake that I do in class, that gets added to a test. So that's pretty cool. I'm going to thank you for doing that. Now, let's go ahead and do that. Like she said, it says 345. I misunderstood the question. I thought you were thinking hypothetically, but it sounds like you did the calculation, and 45 minus 100 is 3.66666 and so on and so forth. So let me correct that. That is 3.67 if we rounded to 2 decimals. Now, what I meant to do, okay, let me correct 3.67. What I meant to do was the 55. And my mind switched the 2 numbers because 55, that's 45 below 100, and I put 45. So let me just do the example that I had intended to show, and that is that if you have 55, then that one is the 3 standard deviations below the mean. And of course, we could verify that and check it by going 55 minus 100 over 15. And indeed, you would get 3. Sweet. Thank you so much for catching that. That's why I give extra credit points for catching a mistake, because that would be very bad. It doesn't happen very often, but apparently my mind switched those 2 numbers, 55 and 45, in my head. And so, like I say, it doesn't happen very often, but I definitely want to give credit for definitely participation and extra credit for catching mistakes. So thank you so much for catching that. All right. Okay, any other questions? Okay. All right, well, then the other piece of this is the percentiles. Now, you might have heard of percentile. Now, so I'm going to tell you a little bit more of what it is. It says, well, the kth percentile, it's denoted with a P with a little subscript, and of a set of data is the values such that K% of the observation are less than or equal to the value. So what does that mean in English? If you see, like, for example, you see this little P with a sub 98 subscript, is a little below there. What that represents, that's the point, that means that 98% of the data is at or below this point. Okay, so it's very often you hear percentiles, like say, if you graduate in the 5th percentile, the top 5%, that would be the 95th percentile. If you're looking at the top 5%, then the 95th, that's the point at which 95% is below. And so very often, again, we use percentile as a comparison to the whole group. And so let's say, for example, this actually happened to me many years ago. Suppose we have, I'm gonna talk about P20. Now, what that represents is the 20th percentile. And so for those of you that might have kids, when you have a baby, you take them to the doctor all the time. And what the doctor does is the doctor, weighs the baby. And of course, they can't stand up. So they measure how long they are, how tall. And I remember a long time ago, my daughter is 21 right now. So this would have been 20 years ago, that when she was 1, I took her to the doctor, and the doctor said that her height was in the 20th percentile. So what that means, that would mean that 20% of the other kids, other kids in the population are at or below her height. So she was kind of small for her size. Okay, and she still is a little bit short. She's and so but anyway, so that's again an outside world example that very often you get when you take a baby to the doctor. They will usually look at the numbers and look at a chart and then tell you kind of where they are in terms of the population, and they do that in terms of a percentile. So knowing what a percentile is, that is really good. Now, all I would expect is for you, at least right now, for a percentile, you don't have to be able to calculate a percentile. You just have to know what it means. What we get to, we get a little bit more into the weeds when we talk about these things called quartiles. Now, a quartile is where you divide the data into 4 equal parts. And you can see here in the diagram, we have what we call Q1, and that separates the bottom 25% from the rest. And then Q2 is the middle, and then Q3. So we have these 3 quartiles that evenly divide the data into 4 equal areas. And you can even see here that the first quartile, denoted Q1, divides the bottom 25% from the top 75%. And so that is the 25th percentile. And we would denote that as P25. Okay. And then Q2, that would be P50, the 50th percentile, also known as the median. Okay, so we talked about median before. Another name for the median is the 50th percentile. And then Q3, that's the 75th percentile, P75. Now, as far as finding these, you can find these quartiles. You can use StatCrunch. All right. So for example, let me go ahead and go to StatCrunch. I'm going to go ahead and I'm going to give you an example. And the data, I actually have some data right here that I'm going to write down and then put into StatCrunch. So here's some data. There are about 16 values here. So they are 2, 3, 5, 7, 8 twice, 9, 10, 11, 13, 16. I'm sorry. I skipped one. There's 13, then 14 and 16. Sorry, there's 14 in there. 17 twice. And then 18 and 20. Okay. So if we were going to find these quartiles, again, we can use StatCrunch to do that. I'm going to go ahead and put these numbers in. Whoops. Hold on a second. There we are. And so we got 2, 3, 5, 7, 8 twice, 9, 10, 11, 13, 14, 16, 17, twice, 18, and 20. Okay, so we have all those 16 values. And if you go to stat, then the summary stats, and in this case, all of our data is involved in var3, and then we can go ahead and compute. And you can see actually all of those values are right there. There's the Q1. So the Q1 is 7.5. That's the first quartile. Or another word is the 25th percentile. And then the median, you can see the median is over here. That's 10.5. So median Q2 or the 50th percentile is 10.5. Put those in. And then you can see Q3 is 16.5 or the 75th percentile. And again, how we did that is we use StatCrunch. Okay. Easy peasy. Can you do it? Yes, no, maybe? Any questions? Sweetie, am I good?
Yeah.
Okay, cool. Like I said, thank you so much for catching that. All right. Now, all right. So I think that's it for that. Oh, wait a minute. No, there's one other little detail. Now, here it says how to find quartiles. But again, because we're using StatCrunch, that takes care of so much of the math. You should be doing the happy dance. All right. Now, the one last little thing that I wanted to point out is this thing called the interquartile range, or the IQR. Now, the IQR is Q3 minus Q1. Now, this is going to come up a little bit later in the next, later meaning the next slide, actually. I was thinking in my head the next section, but it actually is in this section. This thing called the IQR. And so let me go ahead and let's calculate it in this section, in this example. So the IQR, that would be, again, Q3 minus Q1, which in this case is 16.5 to 7.5. And if you go ahead and calculate that, let's see, what is 16.5 minus 7.5? That should be about 9. Now, what's interesting now, this IQR, okay, it says here on this slide, it says it's the range of the middle 50% of the observations in the data. That is, the IQR is the difference between the third and the first quartile. And then you might wonder, okay, well, that sounds very arbitrary. Why would we want to do that? Well, the reason we want to do that is that the IQR is actually a measure of spread. Now, the measures of spread that we talked about are the range and the standard deviation and the variance. But the IQR is another one. And the thing is that the IQR, this IQR is resistant. Remember, what resistant means is that it's unaffected by extreme values. So again, this is another one that if we have data that's skewed right or skewed left, where we're using the median, then we might want to use the IQR, interquartile range, as a measure of spread. Okay, so that's one way to use it. The other way to use an IQR is to determine if a value is an outlier, and that's on the next slide right here. Now, let's talk about what is an outlier. An outlier is an extremely high or low value in the data set. Okay. And so when we identify an outlier, outliers need our attention as far as from a statistician point of view. So I'll tell you just a little bit of a story on outliers. This true story, most of the stories I tell you are true. Several years ago, I was in the math center and a student was working on a project. This was a project in a statistics class. And then they wanted to know how many times per month students had sex. Okay, well, it sounds like an interesting project. And so she showed me the data. She had done a survey and asked students, okay, how many times per month out having sex? Okay. And, she had data of, there were some zeros, 1, 2, 3, 4, 5, some reasonable numbers. And one of them was 35. And it's like, whoa, okay. That is an outlier. Now, of course, an outlier like 35, that's going to throw off your mean. It's going to throw off your standard deviation. And then you got to think, okay, wait a minute, that outlier, we got to think, now, wait a minute, is this person lying? Did they misunderstand the question? Okay. And so in this case, I told, either that person is messing with you, or they probably didn't understand the question, or who knows, but you could probably throw that data value out because otherwise it's going to throw off your mean. It's really not going to be very representative of the data. So the idea of an outlier, we like to identify outliers because they deserve special attention from a statistical point of view. So you don't have to worry about taking a value out. I just told you that story just because, well, it's interesting, and plus it demonstrates, well, the idea of an outlier. But how do we identify whether something is an outlier or not? Well, one way is to calculate a lower fence and an upper fence. And so you can see that the lower fences, they like the lower value, like you look at our data set right here, And if we were going to calculate the lower fence here, we would take the first quartile, which was 7.5, and then go minus 1.5 times the IQR, 1.5 times 9. And if we go ahead and do that, I'm going to use my calculator right now, 7.5 minus 1.5 times 9, and we get -6. And then similarly, if we calculate the upper fence, that would be Q3, which, let's see, what was that? That was 16.5 plus 1.5 times 9, that IQR. And I'm going to do that on my calculator, 16.5 plus 1.5 times 9, and I get 30. So what that means, okay, if we look at our data, okay, we have a lower fence of -6 and a higher fence of 30. All of the data is contained within those values. And so we could say that there are no outliers in this data. Now, certainly if there were any numbers that fell either less than -6 or above 30, then those values would be identified as outliers. Okay. And so you can see that right here in the PowerPoint. I did say that if a value is less than the lower fence or greater than the upper fence, it is considered an outlier. Okay. All right. Any questions so far? All right. Now, then 3.5 is super short, given what we've talked about already. And you can see right there, it says a 5-number summary. And usually when we're in class, I ask people, well, how many numbers are in a 5-number summary? And you don't overthink that. You think, oh yeah, it's just 5 things. Okay. So a 5-number summary, you can see here, is composed of the minimum, that's the smallest value, Q1, now the median, which of course is Q2, and then Q3, and the maximum. So if we were going to go ahead and do a 5-number summary on our data, five-number summary on our data. For example, again, that's the minimum, Q1, Q2, Q3, and the maximum value. And so if we look at our data, let's go ahead and what's the minimum? The minimum was 2 and the maximum was 20. Let's fill those in. And then Q1, Q2, Q3, what were those? That was 7.5, 10.5, 16.5. Okay, and that's it. That's a 5-number summary. Then you're like, oh my gosh, it's got to be easier. It's got to be harder than that. No, that's it. Now, you might say, well, why do we do a 5-number summary? Well, these are certainly 5 numbers that can help you with describe a set of data, because, well, the Q2, that's a measure of center. That's a middle value. Whoops, middle, see if I can spell middle. That's a middle value. And then of course you can use Q1 and Q3 to either find an IQR or you can use the minimum and maximum to find a range. So you can do a few things when you have these 5 numbers. Now, one other thing you can also do is you can make a picture. And this picture I'm going to call a basic box plot. Now, I'll tell you what I mean by a basic box plot. The basic box plot is when you take these 5 numbers. So what you do is you create a number line. So say we go from 0 and I'll go maybe 5, 10, 15, 20, and maybe 25. So we've got a number line that encompasses all of our data. And then what we do is we draw a picture with these 5 numbers. Now, the Q1, that's at 7.5. That's going to be the end of a box. So I'm going to draw a rectangle, and the left end of the rectangle is at 7.5. The right end of the rectangle is at about 16.5. We calculated that. So now make a rectangle between your Q1 and Q3. Okay. That's the box of the box plot. Now, the median is right in the middle. So we're going to put a line right there. That's at 10.5. That's Q2. Then what we do is we draw lines to the minimum and maximum. So where 2 is, I'm going to put a little x at 2. That's not x squared. And a line to the box. And I'm going to do a similar thing for 20. Put a little x at 20 and a line from the box. So this is what I would call a basic box plot. And in the statistical world, if you are going to do a box plot, it uses the 5-number summary. And so I'm actually going to show you this. There's an example. It's later in the class. This is on page 645. Oops. 645. And you can see box plots in action. Now, what this is, these box plots are really neat ways to compare multiple data sets. And in this example right here, they're talking about the strengths of, I think, 4 different types of glue. Okay, so you've got like Cojet, Silister, Kumara, and ceramic repair. Now, by having a box plot and again, you see the number line, you can see and readily compare the bond strengths of these glues. Like, for example, it looks like the Silistor, that's got the highest strength. All right. And again, you see the box plot. You can see the minimum and maximum values. The one in the middle is the median. And then the ends of the box are Q1 and Q3. So it's a really handy way to compare data sets. And that's what I would call a box plot. Now, let me tell you what happened, what you would have seen in the videos, and what the author talks about is what I would say is a modified box plot. That's on the next slide right here. The modified box plot has what happens, the lines don't go all the way to the last data value. what they do is the lines go to the smallest point that is above the fence. Okay, notice here we have the lower fence and upper fence. So what happens is the lines don't cross the fence. They keep going to the last value before the fence. All right. And then anything that's beyond the fence, like for example, you see, then they got like a little star to identify outliers. So this happens sometimes when we have statistical software packages. Sometimes what they will do is identify outliers with a star and then do the fences. And so that is a modified box plot. Okay, so in the statistical world, if we just say basic box plot or just box plot, it's just the 5-number summary, just like what I drew right here. But a modified box plot has the lower fences and identifies outliers. Okay. All right. Now, the last slide here is just it gives helps describe also the usefulness of a box plot and how it compares to what we've talked about before. So 3 of the descriptors for a set of data you can see here in these diagrams can be skewed right, symmetric, or skewed left. And you can see what the box plot looks like. Again, when you see a skewed right box plot, it means you got values off to the right, extreme values or higher values off to the right. When it's symmetric, it's balanced on both sides. And then, of course, skewed left, you can see the line is longer on the left. So a box plot and looking at the characteristics of the box plot can actually help give you a feel for what is the shape of the data. Is it symmetric? If it's symmetric, it might be bell-shaped, and then skewed right or skewed left. All right. Okay. That's it for chapter 3, unless there are any questions. All right. Do we need a couple of minutes? I know we've been doing this for a little bit. So I'll tell you what, I see 10:58 on the clock. Let's go ahead and take just a quick little break to get up, use the restroom, do whatever you do. And whatever you want to do, walk around, go outside if it's not raining. But let's take a little break until 11:05. Just a little short break. Pause the recording. And I will be. Okay, I'm back and refreshed and ready to go. So last call, any questions on chapter 3? Are we good? All right, I'm not seeing any. So let's go ahead and go to chapter 4. Now in chapter 4, again, you would have seen this, it's in the medias. And you can see here what we're going to do. We're just doing 2 sections in chapter 4. And those 2 sections are very related to each other. In fact, it's almost like they could be one large section because they literally go from, I mean, we learn stuff, the technical term, we learn stuff in 4.1, and then we use that, we continue on with 4.2. So those 2 sections are joined at the hip and very related to each other. So let's talk about and it's, well, it says, well, let's talk about the title. Let's start there. It says describing the relationship between 2 variables. And so when we're talking about two variables, we are talking about XY data, a pair of data. So now you might remember, okay, hopefully you remember from algebra, a little bit of graphing. Okay, so this is actually, I'll say 4.1. Now recall graphing from algebra. That's where you have an x-axis and a y-axis. And so what we would do is if you have a point, let's say 3, 4, okay, what that means is we would count 3 on the x-axis and 4 on the y, and that would label that point. 3 on the x-axis, up 4 on the y, that would be the point 3, 4. Okay, so that's what we're talking about when we're talking about describing the relationship between two variables. We're talking about XY data. So what happens is you gather information, 2 bits of information on each thing. So let's continue thinking. Let's just do a little suppose. For example, suppose I gather everyone's height and weight. So suppose I ask, all of you to tell me, what's your height and weight? And then what happens if I say the height is the X value and the weight is the Y value, and if I take that data and I put it on a graph, that's called a scatter plot. Okay, so a scatter plot is a graph. It's a plot of the data. It's a graph of the data. Now, what we want to do with that scatter plot is we ask ourselves, is there some sort of a linear trend? I'll get to that in a second. Let's pretend that I gathered my data. Oops, hold on, color changed. Let's suppose we've got height, again, those are our X's, and weight. And if I plotted them, we would get a nice cloud of points. And we know that typically people who are taller tend to weigh more. Okay, so you can kind of see the way I drew this data. We've got a nice cloud of points. After we plot the data, we ask ourselves, is there some sort of linear trend in the data? Now, in case you're wondering what that term linear, okay, right in there, the first 4 letters spell out line. So when I'm saying linear trend, I'm asking, is there some sort of a line trend in the data? Okay, and so we want to see, okay, is there some sort of a line trend in the data? So that's the question that we ask ourselves. In fact, in this chapter, when we take a set of data, the first thing we do is we do a scatter plot. That's always the first thing. We're going to take a set of data, we do a scatter plot. Then the second thing we do is we ask ourselves, that should be a number 2 right there, and we ask ourselves, is there a linear trend in the data? All right, so that's where we are right now. So let's go back to the PowerPoint and look at the objectives. Now, it says the first one is draw and interpret scatter diagrams. Okay, scatter diagram, that's also called a scatter plot. Okay, that's what I talked about. Then, now the next thing you see this thing called the linear correlation coefficient. Now, you would have seen this in the media. Now, again, long, tedious calculation, we will not do. StatCrunch does this for us. So what we need to do, as far as the compute, we're going to compute and interpret what this linear correlation coefficient means. And that's part of the question, is there a linear trend in the data? Okay, so let me go through a couple of the slides now. I've kind of mapped out where we're going to go with this. And so now I just need to go through a couple of slides, and we'll eventually kind of get back to this correlation coefficient in just a moment. So we have a couple of definitions right here, and you can see here the response variable and the explanatory variable. This is these are definitions that we talked about last time, 2 weeks ago. They were in chapter 1. Okay, so the response variable, again, like it says here, that's the variable whose value can be explained by the value of the explanatory variable. Okay, so that would be, in this case, if we were looking at our height and weight example, then the height would be called the explanatory variable. And then the weight would be the response variable. Response is what happens in the end. We're looking at height. Our taller people tend to be heavier. Okay. Now, we have, I have on the next slide, there are various types of scatter diagrams. And you can see there are various trends in these. So that goes with that question that when we take a scatter diagram, we look to see, is there a linear trend in the data? In the first two, you can see a linear trend in the data. All right. Now in the others, you might see a trend, but it's not linear. And the same is true in the next two, C and D, both are not linear. And then the last one, there is just no trend here. It's all over the place. Okay, so that's just kind of explaining what we're talking about as far as, is there a trend, a linear trend, a line trend or not? And that's what we're going to be exploring here. So the way we measure a linear trend, it's a number, it's called this linear correlation coefficient. And what it says it's a measure of the strength and direction of the linear relation between two variables. The Greek letter rho represents the population correlation coefficient, and R represents the sample correlation coefficient. We're going to be dealing with R. Okay, and we represent only the formula of the sample correlation coefficient. Now this R has ugly formula. Okay, you see that ugly formula? Don't get stressed. Just look at the bottom in green. It says good news. We let StatCrunch calculate this for us. So don't worry. All right. And there's even another ugly formula that's the same as this one. And look at that. Again, StatCrunch does this. So don't worry about that. I only show you this because it might be showing you this in the video, and that's okay. It's okay to have more information and have a little bit of understanding of what we're doing. All right. So I'm not going to talk about these formulas anymore. I'm going to let StatCrunch do that for us. But what I will talk about and tell you more about is what this R means. Okay. Well, the R is always between -1 and 1. So don't be scared of that double inequality. What that double inequality that I have on the PowerPoint is, it just means between. R is between 1 and -1. Now, and then I have this little number line right here that, okay, if the R is near 0, then there is no linear relationship. If the R is 1, that means you've got a perfect positive linear relationship. Now, to bring us back to a little bit of algebra, that means you got a positive slope. And if you got -1, that's a perfect negative linear relationship, which means, again, you have a negative slope. Now, if you're looking at this and thinking, oh man, Mr. Zarsky, wait a minute, I kind of forgot, my algebra or slope. No, we're not going to be calculating any slope. But what we do need to remember, of course, that if we have a negative slope, that means our line is going down, and a positive slope means our line is going up. That's all you need to worry about. Now, if we look on the next slide, you can see I've got various examples, like in diagram A. That's a perfect positive. Everything is lying on a line. And that's what an R of 1 would mean. If your R is 1, it means all of them lie perfectly on a line. And then, well, if you get a little bit of spread between them, like we have here, well, then your R is going to be a little less than 1, but still kind of line. Here you've got a little bit more of a line relationship. That's in picture C. But now the R is 0.4. So you can see the further away these values get from a line, the lower the R gets. To where if you jump to picture G, there's no linear relationship, then the R would be close to 0. And again, H, you can see a trend, but it's not linear. It says right there, not linear. Now let's just go back and look at D. Now, if you have a perfect negative relationship, again, everything lies on a line, then your R would be -1. And then the further these points get away from a line, whoops, I'm not drawing that very well. Something like that. You're getting further from -1. Okay, so again, 1 and -1 are the extremes of perfection, saying that there is a linear relationship, and 0, not so much. Okay, so let's go to actually calculating this linear correlation coefficient. And so what I'm going to do is I'm going to look at page, should be 195 in the book. This is going to be problem number 18. Oh, wait a minute, maybe it's the next page. Okay, there we go. Problem number 18. You can see the data right here. So if we had a set of data, let me go ahead and put this off to the left. The first thing we would do, this is problem number 18, page 196. The first thing we would do is go ahead and do a scatter plot. And then ask ourselves, is there a linear trend? So I'm going to plot the point 210. Let's see, let me mark this off. Let's see, 1, 2, 3, 4, 5, 6 on the x-axis. That's all we need there. And then I need up to 10 on the y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 2, 10, and then 3, 9, 5, 7. That's about right there. 6, 4. And 6, 2. Okay, so we have a scatter plot. So then, of course, again, with a scatter plot, we ask ourselves, does there appear to be a linear trend? And it looks like, yes, it looks like there is. The answer to that question would be yes. So then the next thing we do is we calculate the correlation coefficient. You calculate the correlation coefficient. And again, that is StatCrunch. All right. So what I'm going to do is I'm going to go ahead and go over to StatCrunch, and I'm going to put these values in. Oops. Let's see. Just a second. Let's see. That data was on page 196. I'm actually going to pull out the book. Okay. So the X values are 2. Whoops. Let's see. 2 and 3, 5, 6, and 6. And then the Y values are 10, 9, 7, 4, and 2. Okay. Now, where you find now the directions, okay, on how to calculate a correlation coefficient and even do a scatter diagram. Let me go ahead and show you. In the book, so I had in my notes page 195. 195 has, anytime we're using StatCrunch, if you go to where the exercises are in the textbook, like in this case, it's 4.1, right before that, it tells you how to use StatCrunch. So in case you forget, it's here in the book. Okay, so StatCrunch, if we want to do a scatter diagram, we're going to do graph and then scatter plot. So let's do that. Graph. And then scatter plot right down there. Look at that. Okay, so the X variable would be in var 1. The Y variable would be in var 2. And we hit compute. And there it is. Doesn't that look like fun? That's just like what we did. So then the next thing, well, what if you wanted to calculate the correlation coefficient? Well, what you would do is go to stat, and write that down, stat, summary stats, correlation. Okay, stat, summary stats, correlation. And we go ahead and highlight both of those columns and hit compute. Bam. Now look at that. What that does is, look at that, that calculated, that gave us a negative 9.33. So when we use StatCrunch, R is equal to negative 9 point, whoops, not 9 point, it's 0.933. Okay, and how would we interpret that? Well, the thing is that we would say that this is close, this appears close to -1. And remember, now if I bring up the PowerPoint right there, remember that -1, if it is -1, that's a perfect negative relationship, but this is not -1. This is close to -1. So we would say that there appears to be a negative linear correlation. Okay. So again, this correlation coefficient, this is a number that helps us actually quantify or measure how close the data values fall to on a line. Okay. All right. So we don't, again, we don't need to do any long-winded calculations. We will use StatCrunch to do this for us. All right. Now, the thing is, I think you looked at that, you know, if you looked at that, this negative 0.933 that we got, yeah, I mean, that's pretty close to 1. But the thing is, let's just do a little suppose. Suppose we've got an R of -0.43. I just made that up. And is that close to -1? Is that close to -1? And you'd be like, yeah, I don't know. How do we decide whether something is close to -1 or not? How close is close? All right. So in order to determine if this is close to -1, I actually have a slide for this. That is right there. Look at slide 11 and notice the question that I asked. How close does R need to get to 1 or -1 in order for us to conclude that there is a linear relationship? Okay, so what you have to do is you have to calculate the correlation coefficient. That's step 1. And then what we do is we look at a value in the table. Now, you might be thinking, whoa, wait a minute, what's this table thing that we're talking about? Well, the table will be provided in StatCrunch. Now, the table in the book, it's table A2, and it's page A2 in the book. A stands for the appendix. All right, so let's go. I'm going to go to the book and show you what this table means. Again, this table is in StatCrunch. A2. Whoops. A-2, I guess I got to put in. Now, again, this table is in StatCrunch. It'll tell you, okay, click here for the table. So you don't actually have to look at it in the book. Now, all you have to do is find the critical value that goes with the data set, how large the data set is. The N is the sample size. So if we were going to look at ours, how many points do we have right there? We got 1, 2, 3, 4, 5. So in our example, we have N is equal to 5, which means our critical value is 0.878. Okay, so I'm going to describe it a little differently. It said in the PowerPoint to look at the absolute value, and sometimes that bothers people. What I like to do is a number line. You know that R is between 1 and -1 and 0 in the middle. Now, what this critical value means, that's the point, like 0.878 and -0.878, that's the cutoff. So if the R lands greater than 0.878 or less than 0.878, then we would say that there is a linear correlation. It's close enough to 1. That's the cutoff. If it lands in between, no linear correlation. So in our example of the -0.43, -0.43 doesn't hit the cutoff. So we would say no linear correlation. And then, of course, the first one that we did, the 0.933, there was a linear correlation there. That's close enough to 1. That's what we found earlier. Okay. Now, the idea of correlation, it just means that there is a mathematical relationship between these two variables. They are moving in the same direction. All right. Now, what we have to be careful about is that correlation does not imply causation. It does not mean that one thing caused another. And that's one thing that you have to be careful about in the statistical world. Okay, in the statistical world, again, sometimes they might try to claim that if you eat chocolate, then you'll lose weight. So people that ate chocolate showed a correlation in losing weight. You know, again, that can be silly. And I think what I'll do is I'll show you next time just some silly examples. I'm running a little bit short on time. So we just have to be careful that when we do calculate this R and we find that there is a linear correlation, it doesn't mean that one thing caused another. So that's one thing we just have to be careful about. Okay. Now, what I want to do is now go to the second part of this, and that's 4.2, because what we do is, let me summarize what we've talked about so far. If we want to ask ourselves, are two things correlated? Two things correlated. Of course, the first thing we would do is do a scatter diagram. Then the second thing we would do is ask ourselves, does there appear to be a linear trend? Then if yes, if there appears in the picture, then that's when we go to step 3 and we calculate the correlation coefficient. Calculate R. And then we test it against that critical value. And then again, if yes, then what we can do is we can go to this 4th step, which is right here, and that's where we can calculate the equation of the line that best fits the data. And again, StatCrunch does this for us. Now, one thing you want to remember, and I'm sure you probably remember from your algebra, okay, the equation of the regression line, we've got this little, as y hat, got that little hat on top of it. We say that that's y hat, and you see b1x plus b0. Now, hopefully what that will remind you of, do you remember y equals mx plus b from algebra, where m represents your slope and b represents the y-intercept? Well, it's the same thing here. The b1 is the slope, and the b0 is the y-intercept. And you can see I have those there. But again, the good news is we let StatCrunch do this for us. Now, you might say, well, wait a minute. Hold on, Mr. Zarsky. Okay, I see the y equals mx plus b. I see the slope. I see the y-intercept. But why would I want to do this? Okay, let's go back to the notes when I said we calculate the equation of the line that best fits the data. And the reason we calculate this equation is this is good for making predictions. Based on the data. Okay, so let's go back to our data that we had before. Okay, we remember we found that, okay, the correlation coefficient was 0.933 and said, yeah, there's a linear correlation. In fact, we compared it to our critical value and even confirmed that it goes bigger than 0.878. So now we have permission to calculate this equation of the line. And that is super easy using StatCrunch. So let's go ahead, and I'm going to flip over to StatCrunch right now. Oh, not that StatCrunch. I had two StatCrunches here. Okay. All right. Okay. So here, what we're going to do is we're going to go to stat, regression, simple linear. Go ahead and write that down. That's stat, regression, simple linear. We select the X value. That's going to be in var 1, Y value, var 2. Oops. Compute. And what we see here, you look carefully, it also it calculates the correlation coefficient for you, but it also calculates the equation of the line. Look at that right there where I'm highlighting. So StatCrunch right there, right next to where my cursor is, using StatCrunch, we found that the equation of this line, if var 2 is y, then it's y equals, we'll call it y hat equals 14, and then minus 1.72, I'll just say 727x. And it gave it to us right there. Okay. And again, what this is the equation that best fits the line. So let's see it. All right. And if we go ahead and I'm going to just do a little right arrow thing, look at that. There's the scatter plot, and there's the line that just best fits that data. It just goes right through the middle of the data. And what we do is we use that equation to make predictions. And so those predictions, that should have been described in the video. You'll get to do that in the homework. So what I wanted to do is make sure and tell you about, well, how do we do this if we use StatCrunch? And you'll notice that StatCrunch makes it super, super easy. Okay. So anybody have any questions? I got about 5 minutes left. I wanted to use the last 5 minutes to kind of talk about the test we have in 1 week. All right. So any questions about what we've talked about so far? And again, I know if you didn't watch the medias, then you might be really lost. And again, I rely on you doing the medias, coming into class prepared, having a basic idea of what you're doing, then I can clarify what you need to do and what your homework will look like. And so as far as what you need to do, you don't need to do the long-winded calculations. You can use StatCrunch. Okay. Now, of course, if you do have any questions, you can always ask me during office hours. You can send me an email. Again, stick around after class. I'd be happy to look at another example, or if you try the homework and you see, oh, wow, I have some questions. Again, stick around and I can help you. Now, let's talk about exam next week. Okay. So next Friday, we have exam number 1. Okay. Now, exam number 1 will be on chapters, the sections that we covered, chapters 1 through 4. All right. So you have to have everything done as far as the homework. And it will be on my lab. So the problems will be very similar to what you've been doing in the homework. So the idea is if you've been home and hopefully not having any help, don't do the help me solve this or show me the example, because obviously there's none of that on the test. If you use those learning aids, like help me solve this and show me an example, then that means you just have to do an additional problem without any help. Because if you get too used to using that help, Then you get on the test and be like, I don't know how to do it. Okay, so the exam will be on MyLab. And then, so what next Friday will look like is we will start class, and I'll actually again start early, start the office hours early in case you have any questions, but we will start with any questions. I'll say Q&A. All right, because we covered some new sections today. I would not wait till the last minute to get major questions taken care of. If you got major questions, come see me, email me, go to the Math Center, get your extra credit points. Okay, lots of ways to get your questions answered. So pretty much next Friday should be just a few little last minute questions. Then the second thing we'll do is we'll go ahead and have the exam. You'll have about 2 hours to do that. And then afterwards, you see on the schedule that we have a couple of sections to do after the test. So when the test is done, that doesn't mean we're done. We're actually going to do sections 5.1 and 5.2. Okay, so that's what our day will look like. I know this, I wish we could just take a test and then that's it. But yeah, it's kind of cool that we're meeting once a week, but it just means that we have to get a lot done between each time. And then we can't just take the 4-hour block and then, hey, we have a test, we're done, and then we leave. No, we're going to have some sections to work on. Okay. And then of course, what will happen is that there will be medias due next Friday. Okay, so there'll be some media assignments. So now, how do you get ready for a math test? All right, here's some tips on getting ready for a math test. The first thing you want to do as far as prep for the math test, first thing you want to do is you want to review your notes, learn any red things. Okay, of course, the notes and also the PowerPoints. I'll say PPTs, PowerPoints. They've got a lot of the good notes on there and the things that I consider important. Then you would want to review and rework the quizzes. Now, you can review all of your work that you've done on MyLab. All right, the way to do that is you go to your grade book in MyLab. Okay, so if we go to MyLab just real quick, if you open your grade book, you go to student grade book. And now, obviously it shows nothing for me because I've done no work. But you'll see all of your assignments here, and under this review, there'll be a blue link to every assignment. So you can click on the quizzes or any assignment, and you can review everything through MyLab. And then what I would do, when you think you're ready, then practice some more problems. Maybe practice some homework problems. Oh, and I forgot to, what I should have said, review and rework quizzes and homework. So you got to review the homework and what you did. And again, I'm not going to pull any tricks on you. The test is just going to be problems similar to what's in the homework. So the idea is that if you're good at doing the homework, then you should be good at doing the test. Now, the test, there is no open notes. It's only open brain. You can have a calculator handy if you want, and you will be allowed to use StatCrunch. Okay, and with that, I know we're out of time, but I'm going to keep the recording going. If you need to get going, you can. I'll let it run for a minute in case anybody has any last minute questions, and I'll certainly start the office hours. Anybody have any last minute questions for the recording? Might help? No? Okay. All right. Well, then I'll go ahead and stop the recording and I will start the office hours right now. So just a second, let me go ahead and stop the recording.